Stop stressing it, but you're just kind of like, oh yeah, look at the examples that you drew of odd degrees. Do you see any absolute extrema with those odd degrees? Don't forget, like, that's an extremum, right? But to say it's absolute means it's the absolute highest y value. Is there any way to get an absolute highest y value with an odd degree? Why not?
Because it keeps going.
Keeps going up, doesn't it? Keeps going down? Okay. Well, an absolute extremum. What does it mean to be an absolute maximum? That's the highest it goes, right? Look at an odd degree function. You have an example right here. Is there any way to have an absolute maximum based on that function that you have sketched? Why not?
So the first is never. Are you talking about the second?
So is there any way to have an absolute extreme?
An even degree function has.
Right?
Usually they have to actually sometimes they're always it's not talking about positive.
But I think this is talking about an even degree, doesn't it?
So they're always going to have.
No, not in this one. Specifically an imaginary zero. Yes, you can.
Stay on my mind. Go straight to invisible.
It's because you can't see it, but it would be imaginary as the name for it.
I would say never.
All right, let's talk about it. Yes, Amari. No, you're never allowed this bathroom ever again. Run like a limb bullseye. All right, 11A, an odd degree. Blank has an absolute extrema. Who wants to share what their group discussed? Grace hand. Sometimes. Does anybody want to push back or add on to that statement? We got a thumbs up here. Sometimes has an absolute extrema. Yes, Lexi.
We said never.
Uh-oh.
We also said never.
Uh-oh. Uh-oh, we got some debate going. Okay, so can you give us a reason why you said never?
Because the function keeps going.
Okay, so I say we have some odd degrees over here. Can you explain a little bit more based on this odd degree? Right here, where my laser pointer is?
It could continue doing the same thing.
Can I give the drawing for our?
Sure, draw it.
Yeah, you're going to draw it. The doctor right there.
So it's like it's always increasing.
Okay, it is always increasing. Does that function have an absolute maximum? Or what do you think the absolute maximum is? Be careful, because a lot of students think like that.
Oh.
An infinity is never a max or a min.
Never.
First off, can you ever get to an infinity?
No.
No, so that cannot be an absolute max or min. Absolute max and min can only exist where there was a relative max or min, right? So it has to be a relative that is also an absolute. Is there any way for this to be an absolute maximum for an odd degree?
No.
Why not? I need better language. Where does it keep increasing? On the right side? What's the more mathematical way to say that?
Negative.
Positive interval.
Good day.
As x approaches infinity, the y approaches infinity. That's what you're saying, is that it keeps going, right? But we want more mathematical language than that. Oh yeah, with an odd degree, now it's not always this way, it could be the opposite direction, but with an odd degree, we know that it has opposite end behaviors, right? So it's going to go from negative infinity to positive infinity. So is there any way for a relative max or min to be the absolute highest or lowest? Does that make sense? Okay, so there is no way for that one of those relative max or min to be the absolute highest, because literally it's going to infinity or down to negative infinity. at one of those ends. An even degree function blank has an absolute extremum. Always? Sometimes? Okay, we got a sometimes, we got a always.
Always.
Always? Why do you seem emphatic about that? Why do you say always?
No.
Notice what I relied on was a sketch of an odd degree before, right?
I think it's now sometimes.
Oh, yeah.
There's two even degrees. Do they both have an absolute extremum?
Yes.
Note, for them to have the same end behavior, it has to have either some absolute max or some absolute min. Does that make sense? That, say again. I can't hear you.
The last one has to be sometimes.
Last one has to be sometimes?
Yep.
Why do you say sometimes?
That's the last one.
Oh, this last one.
It's not why it's sometimes.
So that's my reasoning.
It is a sometimes.
This is the last one.
Dude, Evan, you just tore that up.
It is sometimes. But why is it sometimes, Lexi? I actually already have it drawn on the board.
Oh, because of the thing on the board, though.
Because it could have only one with a multiplicity of 3.
Now be careful, we're talking about extrema, not zeros. Right? What those things? Well, this one actually has 1, 2, 3. That would support the idea that there's 3 or more extrema, huh? But that one doesn't. What degree is this? 2. That's a quadratic, isn't it? So, does it have to have 3 or more? No, it could have just 1. It could have 1 or 3 or 5. Notice I'm going by those even numbers, right? It's a sometimes because it could only have 1. Right? I believe this is number 12, is that correct? Okay. What I want y'all to do is very similar to what we've been doing. Go back to the boards that you were working on before, and I want you to answer questions A through I together as a group. We'll come back and in the last 5 minutes have a whole class discussion. Huh? Yeah, for that graph that's there for number 12. Oh my gosh, y'all have me back like, whoa today, go. Run like a wind, bullseye. Come on guys, we gotta hurry. We got 5 minutes to get as many answers on the board as possible. Kennedy, let's wake up. Bree, let's move around. Kennedy, I called on you earlier and you didn't even budge. You've been asleep for a while. How did she sleep?
Right in here.
Just not anymore. Just go get on the, right next to them. You just want to put your answers in there? Oh, yeah, you can. Don't do dumb stuff.
Because if you think about it, good job. But you're racing with the wrong side.
Left to right, right to left. I know. I want to say, oh, I know. I didn't know.
Is it cute or not?
You did. I would know, but he said, Riley, what you did? He said, oh, me too. I'm like, okay, what is happening?
I think it's a quotient. Higher.
I don't know why I know.
Hey, Leah.
I think it's.
Oh, Leah. Are you trying to say our A value is positive?
Yes, I am.
Hey.
Check.
I think I've done that on a lot of tests.
Come on, let's answer as many questions. Guys, we got 3 minutes to answer as many questions as possible.
What they say? We can do the relative
Oh, cool, yeah. Just put the answers up there, y'all. Don't, we gotta move, so just put the answers up. Answers are justified right now.
Okay.
Yeah. I appreciate it, but not right now.
And then for C, the absolute extreme
I'm riding. We got 3 minutes. I can ride it. I got you. I'm a black man. We can fight. Law says.
That's what I mean. Why can't it be?
I'm redoing this.
No.
X intercept has to equal 1.
To be careful, so notice it doesn't say how many intervals, it says use definition to identify the interval. So like when I look right here, it's increasing, right? So that would start increasing when I have the x value negative infinity, and it stops increasing here at negative 2.5. Roughly. It's asking for the actual intervals. 30 more seconds!
Listen, man. I remember that one came out.
What's the name?
Things like the Quinjets from, what's it called? Marvel. Alright, let's head back to our groups and let's start discussing.
Dude, Logan, everyone get Logan. That's hot, oh.
Head back. Alright. Thank you, and thank you, and thank you. Alright, so let's bring it back together. Everyone said that this A value is positive. Let's clarify and make sure we understand why. What do we see that tells us the leading coefficient A is positive? What about the graph? Okay. There's a detail you're skipping there. One thing I would remind, a very simple thing to pay attention to, is we all also recognize that's an odd degree polynomial, right? What's the most basic odd degree polynomial? A linear function, right? So I draw a line like this. Would that slope be positive or negative?
Positive.
Positive, right? Again, it's not a line, but it has the same end behavior as a line with a positive slope. So the leading coefficient is positive. Right, so break it down to the most basic version of that. C, see the no because there are 4 x-intercepts. C, this group over here said no, the x-intercepts has to be 3 or 1. I think that what they're referring to maybe is that the number of x-intercepts for a cubic has to be 3 or 1. But is there another option?
I say 5.
Well,
Yeah, we
hold on. But what I'm saying is this group's, I think they're saying, this is y'all, right?
Yes.
That if it's a cubic, then it has to be 3 or 1 x-intercepts, which is very clearly not what's over there, right? But, say again? 3, 2, or 1. Remember, the x-intercepts go by ones. Most of the other things go by sets of 2, but that's because you can have multiplicities. That's why it can go by ones for those x-intercepts, okay? So it's 3, 2, or 1. I will point out, and so you said that it has 5? 5 what?
Or roots.
I would say, does it have 5 x-intercepts or 5 roots? 5 roots, right? 5 zeros. Remember, it only has how many x-intercepts up there? 4, but one of them touches and bounces away, meaning it's a double root or it has a multiplicity of 2. So yeah, I would probably bet, I saw someone mention that it's probably quintic, right? Not quatic, whatever that is over there, but probably quintic. 4 x-intercepts, 1 with a multiplicity of 2. Alright, domain, we all agreed that it's negative infinity to infinity. Range, we agreed on that as well, so we're good to go there. We did not agree on F. Did we agree on F?
Yes, everyone.
Okay, so there are 4 relative extrema, and some of us said that there are absolute extrema. However, hey guys, if it's absolute, then it is the absolute highest or the absolute lowest. But this is an odd degree, and it goes down to negative infinity. Can you have anything below negative infinity?
It's not possible.
No. Can you have anything above this infinity?
Not possible.
So how many absolute extrema do we have?
0.
There are never absolute extrema for an odd degree polynomial. We're about to lose time, but we're going to talk about H and I. Remind me about that tomorrow when you pick up with H and I. Please notice the question does not ask how many intervals of increase or decrease there are. What are they? Alright, I feel like there's been some good learning today, but what are all of you? Able more. Tomorrow we will finish lesson 3 for sure, which means Monday you will have a talk-to-talk assignment due. And what's due tonight? This Matthew assignment.
What's my What? 8 p.m. Matthew is 8 p.m. I only have like 2.
I wouldn't say she was stupid. She was not wickedly involved all the time. What?
Don't give up on that 5. Because if I didn't get a 5.
Because he said Monday.
What the?
Thank you. Oh, that whole camera got me taking all these photos on your gosh.
I have some work.
Yeah. As usual.
At least a 4.5.
Matthew's due tonight.
At 8:30.
At 8.
Somebody's cup is on the ground.
Did you forget?
Houston had an email today.
I did give it out yesterday. Oh, yes, so you can do it. You can finish everything.
Come on now.
I got 5 days ago.
That's crazy.
Stop holding that girl like that. I'm moving out the door, bro.
What's up?
It's just hot in here. What? It's hot in here for here, Mom. I thought it was hot for a second.
Yeah, listen, you too short for D1.
All right, now. I'm
You are.
gonna get taller one day.
No, like being for real, you too short to be D-line.
Hello.
You can be O-line,
Yes, ma'am.
D-line, nah. 'Cause I'm on D-line.
Sounds great, thank you. No problem. Bye. Good afternoon, Trent. Yes, sir. That's not true.
I've been doing a lot today. I ain't got it today, what you kid. I ain't got it today.
You do.
I don't feel like it. Ooh.
Hey guys, we're not going to use protractors at all. You may want a ruler today, but no protractors.
Get up.
He's cute.
See ya. Guys, log into your calculators. I'm about to send out the poll question. Guys, there's already a bell ringing that we should be working on.
Yes, sir.
What?
Why you didn't go?
I'm gonna take that as a yes, he ain't say shit. You asked him out.
It's on the board though.
Oh, it's not cold.